गुड इवनिंग एवरीवन। हाउ आर यू? कैसे हैं आप लोग? टुडे वी विल स्टार्ट अवर सेकंड लेक्चर ऑफ थर्मोडी. That's again going to be a very important lecture, very important session. And I hope you have completed the previous lecture as well. So right now I am having JNV Mahe, JNV Krishna, JNV Yanam with me. Okay, very good. So I think wait for 1 more minute. After that we will start. Till then, you can revise what we have studied in the previous lecture. In the previous lecture, we have introduced some basic concepts of thermody, that what is thermody, what is thermodynamic system. You remember the thermodynamic system. Remember the thermodynamic variables, pressure, volume, temperature, like internal energy, other factors, entropy as well, but we will discuss them later. Thermodynamic variables. After that, what we have studied work done by the gas, and that was pdv, integration pdv. So that's what we have completed in the previous session. Right now, let's see what we will study in today's session. First of all, there will be a recall test. There will be a very basic recall test. After that, we will complete work done in a cyclic process. There will be a concept test. Then we will study internal energy, first law of thermody, again concept test, then isobaric and isochoric processes in detail. In detail. So till then, now let's start about or with the recall test. Okay. So be ready for the recall test. The recall test is on your screen. What it says. Okay. Answer me whether my voice and screen is everything visible to you. Is everything visible? Just comment in the chat box and then we will start. And for solving the question, you have 45 seconds to solve the question. Try to solve. Answer in the chat box, first of all, that whether everything is visible to you or not. Okay. Take some 40-45 seconds to answer the question. So there is a thermodynamic process AB like this. You need to calculate the work done. What we have learned in the previous session, that area under the PV curve represents work done or gives the work done. So if you can see this AB and the area under the curve with the volume axis, that was the punchline. If you are absent in the previous class, then you can also learn that if you have a PV curve, PV indicator diagram, then area under the PV curve with the volume axis gives the work done. Now you can see we have to calculate this area. If you see this area, if I draw the boundaries of this area, then one boundary is this, another boundary is going to, and this one. Can you see that it is a trapezium kind of thing? It is a trapezium kind of thing. So work done will be what? Area under the curve. So area under the curve will be a trapezium, area of trapezium. So area of trapezium is what? Half. I think you know that what is the area of trapezium? Half into sum of parallel sides. Sum of parallel sides. So these two sides are parallel. These two yellow sides are parallel. And the sum of them, you can see that this length is P naught and this length is 2 P naught. So if you add these two sides, it will be 3 P naught into separation between the parallel sides. And the separation between the parallel sides, if you want to see, this is 2 V naught, this is 4 V naught. So this length will be what? 2 V naught. So the separation between the two parallel sides is 2 V naught. You can see this 2 and 2 will cancel out. So it will be 3 P naught V naught. 3 P naught V naught. Work done is what? 3 P naught V naught. And you can again see, remember one thing, one more thing. There might be a positive work done or might be a negative work done that we have seen in the previous session. So here you can see the process is from A to B. And while going from A to B, the volume is increasing. That means there is an expansion. And whenever there is an expansion, the work done is always positive. So answer is 3 P naught V naught, which is option number C. I think it is clear. I hope this thing is clear. You need to calculate the area. Okay. One more question if I want to ask you, this is just a simple question you need to answer. For example, this is again a PV diagram. This is other question other than this question. Simple question, but what if I say that this is a process or let's say this is a thermodynamic process from A to B. What will be the work done in this process AB? What will be the work done in this process AB? Can anyone answer? Try to answer. I'm looking at the chat box. I'm waiting for your answers here, both from YouTube and Zoom. Okay, okay, okay. JNV Krishna, Mahe, Yaman. Okay. So, okay, no problem. If you can't solve it, I will give you the answer. Look at that. What we need to do, we need to calculate the area under the curve. So AB, if you see that area behind it is nothing but 0. You can see that if you consider the line AB, this is the given graph of PV diagram, PV indicator diagram. So area under it with the volume axis is what? There is no area that this graph is going to cover. So that means work done in this process is what? 0. So in this process, work done is 0. This is again a simple question, but you need to remember this in mind. It will help you a lot. Now, we are going to discuss about the work done in the cyclic process. So first of all, what is a cyclic process? Let's suppose this is a PV diagram. This is a PV diagram. Here, focus at that. Suppose a process starts from point A, goes to B via C, following the path ACB, then returns back to A, following the path BDA. So the initial and final positions, final states, you will say not the position, you will say states. Initial and final state of the system are same. The state initial is A and final state is also A. In that case, the process is known to be cyclic process. I think term is clear. Cyclic process means when initial and final state of the system are same. What is the meaning of state here? State is what? When pressure, volume, and temperature of the system in initial state and final state are same. What is the meaning of state? The values of pressure, volume, and temperature. When these are same, then you will say states are same. So work done in a cyclic process, you need to calculate. Can you see that this complete process is formed of two processes? One is ACB and another is BDA. So what we will do, we will calculate the area of the two processes and then solve it out. So for the process ACB, area will be this one. Try to focus on the screen. This is the area ACB. So this area will represent the work done in the work done in the process ACB. Now for the process BDA, area behind it or area under it will represent the work done. So for the process BDA, area will be this yellow line. These yellow lines will represent the area of the BDA process. Don't get confused. What I'm saying, area under the curve represents work done. I need to calculate the work done in the complete cyclic process. This cyclic process is made up of two individual processes. One is ACB, another is BDA. There were two processes. So I have calculated the individual areas. Blue area is for ACB, yellow area is for BDA. Clear? So that one more thing, if you can see, ACB, in the process ACB, the volume is increasing. That means this area, this work done will be positive because there is an expansion. While in the BDA process, the volume is decreasing. So this is compression. And for compression, area will be negative. Clear till now? Everything is clear. Now, total work done will be the addition, the complete work done will be what? You will see blue area. This is unofficial thing that I am writing in blue area and yellow area. Minus yellow area. Why subtracting? Because blue area is positive and yellow area is negative. So after subtracting, you will get the total work done. You will get the net work done. So if you subtract this area, I'm sorry, my bad. Okay. If you subtract these two areas, what you will get? You will get this portion. You can easily subtract these two areas. What will be remaining area? This portion is the remaining area. So the total work done will be area enclosed by the cyclic process. So this is our punchline. What is the punchline? That for a cyclic process, what will be the work done? Work done will be the area enclosed by the cyclic process. So if you can calculate this area, you will get the work done. Now there are two more punchlines that I will describe here. First punchline is that how you will decide that work done will be positive or negative. For that, there is a simple trick. What is that simple trick? If cyclic process is clockwise, then work done will be positive. You need to remember this thing. And this is very simple thing. If it is clockwise, that means uh, this upper area, or the expansion area is more as compared to the compression area, so that will be obviously positive. So I don't uh, allow you, or I don't suggest you to go for that individual processes. Just go for clockwise or anti-clockwise thing. If process is clockwise, then work done will be positive. If process is another thing is what? Anti-clockwise, then work done will be negative. So try to remember these two things only, clockwise or anti-clockwise. So what we have learned in the cyclic process is what? In which initial and final states of the system are same, one thing. Another thing, how you calculate the work done in the cyclic process, area enclosed by the cyclic process gives the work done. Is it positive or negative? Is it decided by the clockwise or anti-clockwise thing? If the process is clockwise, then it will be positive. And if it is anti-clockwise, then work done will be negative. I think till now every point is clear in this cyclic process. So there will be a concept test for you, a very basic concept test. Try to solve it out. And you will have just 40 seconds. At least try to answer. At least one person should answer. JNV PKD2. Try to answer. You have 40 seconds. I'm again repeating one thing. This thermodynamic is very important for all the exams. In JEE mains, every year, in every shift, at least one question came in every shift. At least one question came in every shift. And this is the pattern from past many years. Every year there will be a question, there will be a question in every shift. So try to, and these questions are doable actually. I'm not saying these are the difficult question like mechanics. You will find some difficult questions there. These questions are doable. So this is a sure shot, and you can score 4 marks out of this chapter. You can grasp those 4 marks. So this is a doable thing. Try to focus. Try to solve. I think 5 minutes, 40 seconds are up for you. So first of all, try to find whether this is a clockwise cyclic process or not. Whether this is a cyclic process or not, first thing is you can see that if it starts from B, then it's ending at B. So this is a cyclic process. I think someone sent me the answer. JNV Krishna is saying C. Okay. Okay, we will find it out. So one thing is, first of all, identify whether it is clockwise or anti-clockwise. You can see this is anti-clockwise process. Anti-clockwise and work done will be negative. So two options are already wrong. These positive options are already gone. I think clear na one thing. Now you have to decide whether the values A and C. Now this is a cyclic process. Cyclic process will be area enclosed by the cyclic process. So this area we need to calculate. And this is the area of the triangle, nothing else. So area of the triangle is what? Half into base into height. I am just writing the formula of the area of triangle. Now base is what? BC. This is what? 100 cc and 200 cc. So this length is 100 cc. This height is what? 100 Pascal. I think you can read the graph now. From here to here, this is 100 Pascal, this is 200, and remaining portion is 100 Pascal. Now you need to put the values. Half base is what? 100 cc. That means 100 into 10 raised to the power minus 6 into height is what? 100 Pascal. So it will be 1 by 2 into 10 raised to the power minus 4. Okay, minus 2. 10 raised to the power minus 2. 1 by 2 is nothing but 0.5 into 10 raised to the power minus 2. But here answer is after first decimal digit. So you can write it as 5 into 10 raised to the power minus 3 joule. This is work done. But this is anti-clockwise cycle. So work done will be negative. So this is our answer. So which option is correct? Option C is correct. And I think JNV Krishna has given correct answer. Very good, JNV Krishna. Now, one more thing, I think someone of you might have confused with the unit cc. What is the meaning of cc? Cc means centimeter cube. Like volume is what? In meter cube, we have considered volume in meter cube. Cc is what? The full form of cc is centimeter cube. This is how you, I think your bike engines are in cc's. 300 cc, 320 cc, Bullet Classic, 500 cc, Thunderworld, whatever. You have lot of variety in there. So cc is what? Centimeter cube. Okay. So we will move further. Now, internal energy. Listen to me very carefully. Now, this is the thing that you should understand very carefully and very quickly as well. Internal energy is what? The energy due to the molecules of the gas is called internal energy. One thing is clear. First thing, the energy due to the molecules of the gas is called internal energy. One thing is clear now. This energy in molecule or this molecular energy is of various kinds. From various sources, this energy may come. Listen, this molecular energy or the energy due to the molecule may come from various sources. Like it may be kinetic energy of molecule. It may be rotational kinetic energy of molecule. It may be potential energy of the molecules, of the surrounding molecules, of the group of a molecules. So there are lot of energies associated with the molecules. Clear? First point is everything is written on your screen, but you need to see the screen later. First of all, listen to me. What I'm saying, it may be due to the kinetic energy or potential energy of the molecule. Now, one more thing. Generally, in this chapter, we will discuss with the ideal gas. We will deal with the ideal gas. So, what is the basic concept behind the ideal gas? So, if you don't know what is ideal gas, then I will give you a small description of the ideal gas. Listen to me. What is an ideal gas? The gas in which any two molecules, any two molecules do not interact with each other. If two molecules are very close, we know that they attract each other. We know that whenever two molecules are close to each other, they attract each other. Then this force is known as molecular force. But the ideal gas is that in which this molecular force is absent. There is no molecular force. That is known as ideal gas. This is the concept behind the ideal gas. Now, one more thing. If two bodies placed near each other are attracting each other, or whatever force they are exerting on each other, then they create some potential energy. There is some potential energy due to these bodies. But here in ideal gas, two molecules, this is ideal gas. These are the two molecules. And these two molecules are not exerting force on each other. That means there will be no potential energy. There will be no potential energy because for potential energy, there should be a force of attraction or repulsion. There should be a force between the two bodies, which is absent. So next line is, for an ideal gas, intermolecular forces are zero. If intermolecular forces are zero, that means the internal energy is due to kinetic energy of the molecules only. Because potential energy is what? Zero. I think this point is clear. Now, this kinetic energy comes from where? Kinetic energy of molecule, you can see that if you heat the gas, if you heat the water, you can see that if you heat the water, if water filled in a container, if you heat it, then molecules start wandering, they start running faster. So kinetic energy increases. In the same way, the kinetic energy of the molecules of the gas is due to the temperature. This kinetic energy depends on the temperature. So what you can conclude here, that internal energy of an ideal gas depends upon temperature only. So whenever someone asks you the internal energy, whenever the term comes in your mind, internal energy in complete thermodynamics, what what should be the first thought in your mind? That this is something related with the temperature, nothing else. This is something related with the temperature only. And if you increase the temperature, the internal energy will increase. If you decrease the temperature, internal energy will decrease, like this way. I think the point is clear. The everything is written on your screen. Have a look at that. Have a read at that. And after that, we will move further. Okay. So here, first law of thermody. So what is first law of thermody? Thermody, I am saying thermodynamics. For example, you have a container. This is the piston. And in this, some ideal gas is filled. And you are giving some heat to it. You are giving some heat to it. What will happen? You will say that temperature will increase. What you will say, if you give some heat to it, its temperature may increase. Another thing that may happen is this gas may expand. And this gas may expand, if I say, then what does it mean? That the piston will or piston may move to this point. And this, if the piston is moving, that you can say the work done is happening. Some work is being done. So what I'm saying, if heat is given to a thermodynamic system, then it may perform some work or its temperature may change. Two things may happen. And these two things can be summarized in a simple equation. And that simple equation is Q is equals to delta U plus W. Delta U is what? Change in internal energy. W is what? Work done. So this total theory can be summarized in a simple equation. Q is equals to delta U plus W. And this equation is known as first law of thermodynamics, I mean to say, thermody. Again, one more thing, on which principle this first law of thermodynamics depends. You can see that heat is given, work is performed, and internal energy is changing. So in the complete process, you can see all these terms are related to the energy. So this is nothing but the conservation of energy. So first law is nothing but the conservation of energy. On which fundamental principle first law of thermodynamics depends? It depends on the conservation of energy. Conservation of energy. I think clear this point. Remember the equation Q is equals to delta U plus W. Q is what? Heat. Delta U is what? Change in internal energy. W is what? Work done. Now there are some sign convention that you should remember. Read it out. What are these sign conventions? If you give some heat to a system, for example, this is a system. If you are giving heat to it, then this heat will be positive. Clear? If the system is rejecting some heat, then this heat will be negative. I think first 2 point is clear. If you give some heat to the system, then it is positive. If heat is rejected by the system, then it is negative. You have to take this consideration. Again, next is expansion is what? Positive, that we have already learned. Compression is what? Negative. Another thing, if temperature increases means internal energy will also increase. And if internal energy increases, that means it is positive. And if temperature decreases, that means internal energy is negative. Now, repeat it with me. Heat given to the system, positive. Heat rejected by the system, negative. Expansion, positive. Compression, negative. Temperature increases, then delta U is positive. Temperature decreases, then delta U is negative. Okay. After, try to remember these. Try to write it down actually. Because in chemistry, these sign conventions may be of something here and there. So try to remember that. Now moving further. Again, there is a very simple concept test for you. Okay. What you need to do, I think you have 1 minute of time. That will be enough to solve this question. Try to read it out. The question is very simple. Everything is mentioned. Please give it a try. Because if you try it out, only then you will learn. Otherwise, the learning process will not be the same. I am reading the question till then. An ideal gas is taken from A to C. From A to C. Okay. Via three different paths ABC, ABC, this path, AC, and ADC. Okay. The internal energies of gas at A and C are P naught V naught and 5 P naught V naught respectively. That means at A, internal energy is P naught V naught, and at C, internal energy is 5 P naught V naught. Clear? Okay. This is the thing that we have seen here in the first three lines. The total heat supplied during the process ABC and ADC respectively is. Okay. So during the process ABC and during the process ADC, what is asked? Total heat supplied was asked. So first of all, we will focus our thing on what is asked. They are asking us the total heat supplied. So whenever they are asking about the total heat, the first thing that should come in your mind is heat is only given in the formula of first law of thermodynamics. That means you need to apply first law of thermodynamics. What is first law of thermodynamics? Q is equals to delta U plus W. This formula you should apply, or you need to apply this formula only. Now, delta U is the change in internal energy. If you can calculate delta U and W, then you will get the answer. Clear? So delta U I am calculating, let it be equation number 1. Delta U is what? Change in internal energy. Final minus initial. Initially you are at A and finally you are at C. So the change in internal energy is what? UC minus UA. And if you place the values, UC is what? 5 P naught V naught. This is P naught V naught. So it will be 4 P naught V naught. You got delta U. Now, in all the processes asked ABC and ADC, this delta U is for both the processes because A to C ultimately you are reaching. Now, I am taking first process ABC for process ABC. If you take the process ABC, then work done will be what? You can see work done ABC process can be broken into two parts. One is AB, another is BC. AB and BC. And I have told you earlier that work done in the process BC will be 0. Why 0? Because area under BC is nothing. There is no area enclosed. There is no area under the curve BC. So work done under AB is the total work done. So work done will be what? Area under AB. Area under AB, you can see that this is going to be a rectangle. This area you need to calculate. Area under AB. This is what you need to calculate for the work done. And this area is what? Length into width. So work done will be what? V naught, 2V naught. So it will be V naught, 2P naught minus P naught. That is from this complete area. This length is V naught and this height is what? 2P naught. That is 2P naught into V naught. This is what? This is the complete work done in the process ABC. So from 1, if I place these values in equation 1, Q is equals to delta U is what? 4P naught V naught plus W is what? 2P naught V naught. So Q is equals to 6P naught V naught. This is for process ABC. So for ABC process, work done is 6P naught V naught. You can choose the answer from here as well till now, but we will solve for the next process as well so that things might clear. Now, for process, next process is what? ADC. ADC. Now look at the process ADC. Again, I am going to calculate the work done in the process ADC. So work done will be what? Work done in the process AD plus work done in the process DC. In the process AD, let's suppose this is 3 and 4. In the process 3, from A to D, work done will be 0. And from D to C, work done will be area. I will represent this area with the red pen of this area. This area. This is going to be the work done in the process DC. This is the rectangle. And rectangle of sides V0 and P0. So work done will be what? P0, V0. Again, you can place the values in equation number 1. From equation number 1, Q is what? delta U plus W. Delta U is what? 4 P naught V naught. And W is what? P naught V naught. So Q is what? 5 P naught V naught. So the correct answer for this question is option number C. Option number C. 6 P naught V naught and 5 P naught V naught. What's the problem? Why you can't solve this question? I think the question was easy, but it needs some one more thing. Question will be easy on the easier side in this chapter, but there will be sort of calculation that is going to be involved, and your thinking process that is to be evolved by these simple examples. Later on this in this chapter, we will do some difficult examples as well. So try to solve it out. And I don't know how you will practice these questions again, but you should practice actually. Now, what is we are going to start about the isobaric process. We will study it. This is going to be our last topic of the today's class. Isobaric process. The thing is very simple. We have discussed it earlier. That process in which pressure remains constant. So there is no problem with that. Next thing that we will discuss here, if you know that the what is the ideal gas equation. The ideal gas equation is what? PV is equals to nRT. In this process, pressure is constant. Number of moles are also constant. R is the gas constant. So what will remain? It remains as V is proportional to T. V is proportional to T. This is the main line of the isobaric process. If this is the thing, V is proportional to T, then you can also write it as V1 over V2 is equals to T1 over T2. This is the another thing. I am writing it in terms of V1 over V2 equals to T1 over T2, and someone might have written it as V1 over T1 is equals to V2 over T2. So I think there is no problem with these sort of things. You can completely align things. But what is the most important thing that you need to remember is V is proportional to T. So for isobaric process, V is proportional to T. That is to be remembered. Next thing is what? Indicator diagram for the isobaric process. Indicator diagram, you know that there are three types of indicator diagram. So one is PV diagram, pressure volume. Pressure volume diagram, if I draw, pressure remains constant. Pressure remains constant, that means the line should be like this. In this complete line, pressure is constant. Like at this point, at all these points, pressure remains constant. I think clear. So this is the graph of isobaric process. Another one is this is between pressure and temperature. Again, one more thing, pressure is going to be constant. So pressure is going to be constant. The graph will look similar. At all these points, pressure is same. Something P naught, something P naught. Next is volume and temperature graph. Volume and temperature. What we have seen for isobaric process, V is proportional to T. That means graph should be a linear line passing through the origin. So graph is like this. This is the graph. So I think the indicator diagrams are clear to you. PV, PT, and VT graph. Now the next thing is we need to calculate the work done in the isobaric process. So work done in the isobaric process is what? Whenever you need to calculate the work done, the one thing that should come in your mind that we have seen that work done is nothing but integration PdV. That's what we have seen. From where to where? from initial volume to final volume. That's got the key formula of the previous session. We can easily solve it by the area under the PV curve, but still the basic formula, the basic work done formula is what? PdV. Here you can see that process is isobaric. That means pressure is constant. So constant things can be taken out of the integration. So it will be W is equals to P is constant. Integration of dV will remain. And integration of dV is what? V. If you put the limits, it will be V2 minus V1. So W is equals to P V2 minus V1. Or you can say W is equals to P delta V. This is the work done in the isobaric process. This is the very simple question. The very simple thing, isobaric process is completed. In the next session or the next class, we will complete two other processes and some very good examples we are going to take that will clear a lot of concepts. These are the frequently asked questions. So W is equals to P delta V. I think it is clear now. Okay, so I think time is up for now. So we will end the session. If you have any doubt, you can ask me, JNV Gonda. Otherwise, we are leaving the session. We are ending the session now. Time is up. Is everything clear till now? The examples, the concept test. Okay, so I'm